Okay, let's talk just a little bit more about existence and uniqueness in writing down the solutions of systems of equations. So let's start with this one. This one's already almost in RREF form. There's one reason that it's not completely in reduced row echelon form. Why is that? So yeah, it's right here. That should be a 1 rather than a 2. We could divide all of row 2 by 2 and get it completely in reduced row echelon form. But let's go ahead and see what we can do about writing down the solution to this thing. Keep in mind it's x1, x2, x3 equals, and then number, because this is an augmented matrix. So the first row would say x1 equals 0. The next one would say x2 equals 0. And the last one would say that x3 equals 1. Easy enough. Apparently the original system of 3 variables and 3 equations, the only solution was 0, 0, 1. By the way, notice we have 3 pivot positions, 3 pivot columns, and those 3 pivot positions and 3 pivot columns go with the fact that we have 3 rows to mean there are no free variables, and that's and that there's a single solution. Okay, let's move on to the next one. Let's take a look at this one. We could just start by writing down x1, x2, x3 equals. But notice the pivots. Let's point that out first of all. Let's get on the right layer. There's a pivot here, and there's a pivot here. There's another column, there's another variable. All right, so apparently x3 is going to be a free variable, but let's take a look at that. So the first row, and again, this isn't fully in RREF form, but let's work with it anyway. Let's say that x1 minus 2x3 equals 9. And the next one says x2 plus x3 equals 3. And because we like to fully write down a solution, let's solve. So let's say x1 is going to be 2x3 plus 9. x2 will be negative x3 plus 3, and x3 is free. It's just x3. So there's all of the infinitely many solutions with your free variable being x3, the one that's not a pivot column. Right, there's pivot column, there's pivot column. x1 and x2 columns. x3 is free. And again, if I wanted a particular numeric solution, I could just say, how about, let's say x3 needs to be 6 for some reason. Now I should be able to write down x1 and x2. So if x3 is 6, then x2 is going to be negative 6 plus 3, so x2 would be negative 3. And x1 will be 12 plus 9, which is 21. So there's one solution. I could pick another solution by saying, what if x3 is 0, just to make it easy on me. Then x2 would be 3, and x1 would be 9. There's another solution. Okay, so this is one of the infinitely many solutions cases. By the way, as I make these videos, I know I'm doing a ton of computations by hand. If you ever catch a mistake, let me know. I'm sure I'm going to make mistakes, and I'd be very happy to fix it. I don't want my mistakes out there. Anyway, okay, let's take a look at one more example. Let's take a look at this one. Also not completely in reduced row echelon form, but I'm going to claim we can stop right here. even if we wanted to go to reduced row echelon form, there wouldn't be any point. Because look at the last row here. Apparently there's an x1, x2, x3, x4, and equal signs. But look at what that last row says. It says 0x1 plus 0x2 plus 0x3 plus 0x4 equals. So that basically says, get on the right layer again. So picky. It basically says 0 equals 5. That's what that last row translates into, which it doesn't. 0 does not equal 5. I know this might shock you. But it's true that it does not. Those are not equal, and this is an unsolvable equation, right? There's nothing I can plug in for x1, x2, x3, or x4 that will make that row true. So this is a no solution. The solution does not exist. Okay, I think with that, you should be fully prepared to tackle the homework. I might do one more video just as an example from the homework, but I think these 3 videos constitute the lecture for this section. So feel free to dive right into the homework.